Hello everyone, my name is Anand Suthar and welcome back to my LeetCode problem solving series. Today we are solving the longest substrings without repeating characters. LeetCode problem number 3. This is a classic sliding window problem asked at Amazon, Google and Microsoft. I'll show you the clean solutions using an unordered map to track the character positions. Let's dive in. Here is the problem. Given a string, find the length of the longest substrings without repeating characters. Substrings mean the contiguous characters. Let me show you an example. In example 1, we have given a strings ABC, ABC, BB and its output is 3. The substring is ABC has no repeaters. Similarly in example 2, 3 and 4. We need an efficient solution. Sliding window is perfect here. Here is the sliding window idea. We maintain a window that contains only unique characters. We use the 2 pointer left mark to the start of the window. I move forward. As we move I through the strings, if we have the characters that's already in our window, we move left past its previous occurrence. We store the last index of each characters in map. This why our window always has a unique character. Let me write the code. We start by setting up our the code trackers tools. First we create an unordered maps code last index. This map goes to the several over the memory banks. It will remember the exist index positions where we saw the character each. Next we declare two integers variables left initialized to 0 which repeat to the starting left boundary or a slide window and max initialized to 0 which will be tracked over records holding the longest substring length we have found so far. Now we kick off our for loop using a variable I. The variable I acts as the right boundary of the sliding window, starting it forwards across the string step by step. Inside the loop, we grab our the current characters S at I and store it variable called C. This if statement right there is the absolute brain of the entire. We need to check if we just ran into the duplicate letters that is already inside the active window. We check the two conditions linked by the logical end. First, index at I dot find C is not equal to last index at dot check if character C is already exist in a map. Second, last index at C is greater than equal to left. Check if the last records position of this character falls inside our the after or current left boundary. If both are true, it means we have the duplicates inside the window. To fix this instantly, without looping backward, we teleport to our left boundary forwarding to left at C plus 1, which kicks the old duplicates right out over the active window. Once the window is safely cleared of duplicate, we update our memory bank. We log to the current character C into the last index and set the value to I, updating its most recent position. Then we calculate the current window size using the formula I minus left plus 1. We compare this current size against our historical records using the max functions and save the largest value back to the mean line. The loop repeats until the right boundary I reaches the very end of the string. Finally, we return the max length which holds our winning answer. Because the right boundary I only talks across the string exactly once, over time its time complexity is placed past on. Our space complexity is O of mean m comma n, where m is the size of the alphabet because the characters entering store in a hash map. Let me submit this and it passes. That's the longest substring without repeating characters using a sliding window with unordered map. Key points to remember. Use a sliding window with a left pointer. Store the last index of each character in map. When the duplicate found, move the left past to the previous occurrence. Window always has a unique characters. If this helped you, please like and subscribe. I'm Anand. Thanks for watching. I'll see you in the next problem.